Alright, since I don't know how to make a tutorial video like Professor McGregor, I'm going to do it my way. I'm going to open PowerPoint here, scroll through the theme, pick one. Oh, that seems real good. Okay, I want to do a let's practice problem from topic 18, applications of stoichiometry. Now this comes from video D. After we've learned about precipitation and solubility in video C, molarity and dilutions in video B, and aqueous solutions in video A, we can use all of that and use it for this problem. Let's practice problem number 2. If you add aqueous potassium phosphate to an aqueous chromium 3 sulfate, will it precipitate form? Write the ionic equation that represents this reaction. Be sure to include states, balance your equation, and hint, remember to consider your solubility rules. Alright, the first thing I'll do is write the equation. So, potassium phosphate added to chromium 3 sulfate. Don't quite know how to work the subscripts here, so I guess I'll just manually change each font size. Alright, everything there, little adjustment there. Now let's include the phases. Okay, what does that yield? So this is a double displacement reaction where reactant anions are exchanged with product anions, and the general formula for this is AB plus CD yields AD plus CB. Now let's assign the variables. A is potassium, B for phosphate, C for chromium, and D for sulfate. Following this, A potassium will make friends with D sulfate, and B phosphate will get married to C chromium. The chromium will come first in your reaction. So that's how we're going to use the general formula to figure out what our products are. So now we're going to have combining potassium phosphate and chromium 3 sulfate yields potassium sulfate and chromium 3 phosphate. Now here comes the balancing act. Let's focus on the charges of each ion. Potassium has a +1 charge, phosphate has a -3, that's why there's 3 potassiums to 1 phosphate. Chromium is a transition metal, so we'll look to phosphate to help us determine the charge of chromium. Sulfate happens to have a -2 charge, but there are 3 of them, so chromium needs to fit a -6 charge. There's 2 chromiums, making each chromium a +3 charge. So, looking at the product side, potassium is now buddy-buddy with sulfate. How many potassiums with a +1 charge will be needed for a sulfate which has a -2 charge? So let's have 2 of those. And looking at the chromium and phosphate relationship, 1's enough. So after we've added all the coefficients, that's our balanced reaction. So let's work with that for part 2, which is about solubility. So let's look at the rules. We need to know about what happens to the phosphate when it's combined with chromium, and what happens to potassium when it's combined with sulfate. Rule number 3 from video C should help us. It says fluorine, sulfur, carbonate, chromate, and phosphate salts are insoluble except for those containing group 1A cations. Our phosphate is combined with chromium, which is not from group 1A, and that's going to be our precipitant, and that, let's write a little parentheses S. Now, number 5 from video C states sulfate salts are soluble except when combined with silver, mercury, lead, calcium, strontium, and barium. In our equation, sulfate is combined with potassium, which is not one of the exceptions listed, so that's an aqueous. So part 1 asks, will it precipitate form? Yeah, based on the solubility rules, chromium 3 sulfate, chromium 3 phosphate will be our precipitate. So let's write the states, aqueous, 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 solid, making sure that we know what they are. That's going to be real important for when we focus on part 2, which is the net ionic equation. So since we have already found out the charges for each individual ion, we can separate the compounds into the 2 parts it's made up of. And because in chemistry we're only interested in the atoms that were actively involved in the formation of the product, those whose structures have not changed over the course of reaction, we can eliminate all the ions that have not changed over the course of reaction. So the ones that have stayed the same on both reactant and product side are pretty much boring to us. So we can, let's write it out for net ionic equation. Alright, So we have potassium with the +1 charge, aqueous, plus phosphate with a -3 charge, plus chromium 3+, plus sulfate 2-, and that'll give us what we have. Let's highlight what stays the same so we know which ones to cross out, delete, eliminate, forget about. Actually, no, don't forget about them. That's kind of mean. So, all right, let's delete them. Delete, 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 and here we are. That is the net ionic equation. Whoa, something's wrong. Alright, let me just go back and fix it. There shouldn't be a 2 in front of the chromium 3 phosphate. Alright, so that was the actual net ionic equation. The end.